Hi guys, welcome back to your next to last lesson on application of quadratics. Just a couple of reminders and announcements. Don't forget that if you have questions, just email me at bmcneely@riversidehighschool.org. Make sure you're using your school address and using proper email etiquette like we talked about in the last few videos. Thursday is the last day of the regular school year before remediation week begins. Get in those missing assignments and make sure that right now you get out a pencil and paper and be ready to take notes. You're definitely going to want to have notes on today because today's a new topic for you. Quarter 4 ends May 21st. If you're passing with a C or better by then, or if you're happy with your grade, you're done. If you are not happy with your grade or you don't have a C or better, you're going to have to keep working for an additional week. The bonus point project is due May 22nd at midnight. It is worth 20 points, which is the same thing as 2 e-learning assignments. And the expectations and rubric for that project can be found on the Haiku page. We've really designed it so that it can't hurt your grade. It can only help your grade, so make sure you take a look into that. I really enjoy hearing from you about your celebrations, announcements, and struggles. So tell me what's been going on with you. So let's start with some review. So far, we've always been given a quadratic or a quadratic equation to solve and graph. Today, we're going to write our own quadratic equation based on a word problem first and then solve. By the end of our lesson, you'll be able to write and solve a quadratic equation based on a word problem. At this point, we are nearing the end of our lessons on quadratics. If you're having trouble solving, graphing, identifying features, using factoring, using the quadratic formula, you should go back and review those lessons or come to some office hours and let me know what you're having trouble with. Let's start with the area of a rectangle. If I have a rectangle, it looks like this, and I know that I have a length and I have a width. The area of a rectangle is length times width. So let's see if we can add to that. It says the length of the rectangle is, that's telling me that we're getting ready to talk about the length. The length is 6 inches more than the width. So now I have a formula that includes just one variable instead of two. I can write this area in terms of the length times the width. So I can do 6 plus w, which is the length, times the width. I can actually then distribute, so this becomes w squared, because w times w is w squared, and 6 times w. So we have written our equation, and now we have our equation to use here. Now it tells me what the area is. The area is 91. So I have w squared plus 6w. Now let's go back to what we know about solving quadratic equations. This has to be equal to 0. So we're going to subtract 91 from each side. So this becomes 0 equals w squared plus 6w minus 91. And then in order to solve any type of equation that looks like this, we're either looking at factoring or quadratic formula. Well, I don't know off the top of my head what the factors of negative 91 are, so I'm going to instead use the quadratic formula. So the quadratic formula starts with, I'm doing C right here, negative 6 plus or minus the square root. B squared is 36 plus negative 4 times A times C all over 2 times a. We always simplify what's inside the square root first. So this becomes 36, and then negative 4 times 1 times negative 9 is positive 36 all over 2. And then this is negative 6 plus or minus the square root of 72 all over 2. This would not have been factorable anyway because 72 is not a perfect square. So we're going to do the square root of 72. And so we do negative 6 plus or minus, that rounds to 8.48, so that's 8.5 divided by 2. And then we're ready to split this up into two problems. Negative 6 plus 8.5 divided by 2, and negative 6 minus 8.5 divided by 2. Negative 6 plus 8.5 divided by 2 gives me 1.3 or 1.25. And negative 6 minus 8.5 divided by 2 gives me negative 7.25. This isn't always the case, but sometimes when we do application problems, we throw out negative. I can't have a length of a side that's going to be negative, so I'm going to throw that one out, and I know that this is equal to 1.3. Now we need to think about, is this our width or our length? Well, look back at your equation. We used a w, which means we were finding the w for this. So I know my width is 1.3, and I know the length is 6 more than that, so I add 6 to 1.3 and get 7.3. So my dimensions are 1.3 by 7.3 inches. Make sure you have all this written down before we move on. You'll want to have it as a reference to look at when we do our IP today. All right, you pause the video and see if you can try this one now. Welcome back. You should have started by drawing your rectangle. And you know we have a length and we have a width. It says one side of a rectangle is 4 inches shorter than 3 times the other side. So I'm going to say that we don't know the width again. So the length is what we're looking at here. It's 4 inches shorter than 3 times the other side. And we're going to find the side lengths if the area of the rectangle is 310 inches squared. So remember, we know that area is length times width. We know that the length is 3w minus 4 now. And we know the width is just the width. We're going to distribute. So we have 3w squared minus 4w. So my formula that I'm going to use is 3w squared minus 4w. Now I know that the area is 310. So I have 310 inches is equal to 3w squared minus 4w. Well, this is a quadratic equation because I have a w squared and a w, so the only way to solve that is to get it in standard form. So we subtract 310 from both sides. We get 0 equals 3w squared minus 4w minus 310. Now, this is a quadratic equation in standard form. The only way to solve that is using factoring or quadratic formula. Again, I'm not trying to do a times c and get negative 930 and try to figure out how to factor that. I'm going to use quadratic formula. Factoring might have worked, but I'm not going to mess with it. It's just too much. So I'm going to do c over here so that I have some room. That is negative b, so that's a positive 4, plus or minus the square root of b squared, plus negative 4 times a times c, all over 2 times a. So this becomes 4 plus or minus the square root of 16 plus, I'm going to do 4 times 3 times 310. And that gives me 3,720 divided by 6. I'm going to add 16 to that. So that gives me 4 plus or minus the square root of 3,736 divided by 6. I'm going to find the square root of that answer, and that gives me 61.1. So it's 4 plus or minus 61.1 divided by 6. Now I'm ready to split this up into two problems. 4 plus 61.1 divided by 6, and 4 minus 61.1 divided by 6. Well, this is going to give me a negative length, and I can't have that, so I'm going to just use this one. 4 plus 61.1 divided by 6, 10.9. Now, that's one side, that's the width. The width is 10.9. The length is times the width minus 4. So we do 3 times 10.9 minus 4. 3 times 10.9, hit enter, divided by 4, minus 4, gives me 28.7. So the width is 10.9 and the length is 28.7. Make sure you've written this down before we move on to the next type. All right, so some key phrases that you're looking for when you work on these are things like maximum height. That would be the vertex, because you know that if we're looking at something that's thrown into the air, the maximum height is right here, which is our vertex. Or if it reaches the ground, then you're saying that the height is 0. If I'm all the way down here, if I throw something into the air and it hits the ground, it's laying directly on the ground. That means that the height is equal to 0. So I want you to put these in your notes so that you know what you're looking for, and keep an eye out for these phrases in the next few slides. So for this one, we're throwing an object upward from the top of a 1,200-foot tall building. So we've got this building here, and we're going to throw something from the top. So it's going to go up, and then it's going to eventually go back down. We don't have to write our own formula for this one. They're giving it to us. The height of the object is given by this t seconds after we threw it. H equals negative 16t squared plus 16t plus 1,200. So what we've got is this 1,200-foot tall building. Here's our vertex up here at the top. Here's where the height equals 0 when it hits the ground. So the first question asks, where is the object 3 seconds after we throw it? That's telling us that the time is equal to 3. We don't know the height. So if we substitute into our equation, negative 16 times 3 squared plus 16 times 3 plus 1200, I don't need to do any factoring or quadratic formula to solve this because I can just simplify this. Order of operations says exponents come first. So we do 3 squared and get 9 for that one. So that becomes negative 16 times 9. Now we're going to do all the multiplication and division from left to right. So negative 16 times 9 is negative 144 plus 16 times 3, which is 48, plus 1200. And so the height 3 seconds after we throw it is negative 144 plus 48 plus 1200, and that gives me 1,104 feet. Now for a problem like C, it says when will the object reach its maximum height? Well, what that's saying is look for your vertex. So the time is equal to negative b over 2a. We've been looking for that variable, so instead of an x, we've got a t. So t equals negative b over 2 times a. So it's negative 16 divided by 2 times negative 16. That gives us 1/2 or 0.5. So essentially, it reaches its maximum height about a half a second after we throw it. It starts to go back down pretty quickly. Now, how high will it be? Well, this is very similar to what we just did here. We have the time. The time equals 0.5. We want to know the height, so we're substituting into the equation. H equals negative 16 times 0.5 squared plus 16 times 0.5 plus 1200. Order of operations says exponents first, so it's 0.5 squared, which gives me 0.25 plus 16 times 0.5 plus 1200. Negative 16 times 0.25 gives me negative 4. 16 times 0.5 gives me 8. Then I add the 1200. Negative 4 plus 8 is 4, plus 1200 gives me 1204. So essentially what we've just found is the axis of symmetry and the vertex. It reaches its maximum height after 0.5 seconds, and at that time it's 1,204 feet up in the air. Now, when will the object reach the ground? Remember, that means that h is equal to 0. It is flat on the ground. So it's 0 equals negative 16t squared plus 16t plus 1200. Again, I don't try to factor these big numbers like this. I'm going to jump straight to the quadratic formula. So it's going to be negative 16 plus or minus the square root of b squared. So b squared is 16 times 16, which is 256, plus negative 4 times a times c, all over 2 times a. So this becomes negative 16 plus or minus the square root of 256. A negative times a negative is going to be a positive, so I'm doing 4 times 16 times 1200. That gives me 76,800 divided by negative 32. This becomes negative 16 plus or minus the square root. Add those together. We get 77,056 divided by negative 32. Now I'm going to find the square root of that number. That gives me negative 16 plus or minus 277.6 divided by negative 32. Now I'm ready to split it up into two problems. Negative 16 plus 277.6 divided by negative 32, and negative 16 minus 277.6 divided by negative 32. This one's going to give me a negative number, so I'm going to throw that out. Negative 16 minus 277.6, and hit enter, divide by negative 32, is 9.2 seconds. So 9.2 seconds after we throw it, it'll hit the ground. All right, we're going to stop here. You're going to go back to haiku, and you're going to find part 2 of these videos for today.